say, let me see. Well, anyway, there might be several other names. But look, among this one, the Niels Bohr is a very special. And in the quantum mechanics, there is a two big group, actually, in the beginning. One is the Niels Bohr's group. Another is de Broglie and Schrödinger. This is not the same school. De Broglie, Schrödinger is the same idea. You see that the Niels Bohr's group is another Heisenberg. It's matrix dynamics. But the Schrödinger and de Broglie is wave mechanics. So there's a little bit different. Of course, Schrödinger prove these two dynamics is same. Now, what is maybe in the end of that, sir, you, Niels Bohr's group, what do you call this school? This is a very important school in quantum mechanics. How do you call it? You gave up? Then next one. You don't know. How about you? You come just so I see, but I'm familiar with your face. Last time I saw you. So I'm asking the question that in the quantum mechanics, there is a very important group. It's called school, led by Niels Bohr. How do you call it, this group? Behind, they gave up. Okay, then next one. Yes, the Copenhagen's group, or Copenhagen's school. But think about it. Look, this is a very interesting. Why Copenhagen? You see that till that moment, you can count that the center of the study of the physics was maybe German, like Sommerfeld, all great people, Gauss, okay, Copenhagen, and sorry, the German, or maybe Britain, great people, Maxwell or Hamilton, he said, all great people there. And then France, Lagrange, Liouville. You see, it's a great country. But then why Copenhagen? Don't you think it's strange? But that is, the research and science. You don't need to live in a huge, great country. One day, your group becomes the center of the world. That was a typical example of the Copenhagen. See? Okay. I didn't prepare this talk, but it was nice. So then let's go about the little bit of the history. Anyway, this university might be the center of the world in the near future, I believe. Okay. So let's go. Today's talk is that I'm now telling a very several fundamental concept of the physics and several keywords. And especially that in the modern day, the nonlinear dynamics, broken time symmetry, or instability, all this concept becomes very, very important. Therefore, I want to guide my talk in that direction. And especially, today I will explain not so many formula, but the next lecture might be go to the very important famous theorem. It's called the Poincaré's theorem for the non-integrability. That I will prove it. And the proof is so simple, but this is so important theorem to talk about the dynamics. Therefore, I will finish to just introduce what is the Poincaré's theorem and the non-integrability. And this is related to breaking symmetry. Okay. Actually, I need a lot of the blackboard. Yes, but first, let's go. You know the equation of motion is a Newton's equation, but in the later, it becomes more elegant to describe the dynamics. And essentially, why they try to make elegant is they try to solve very complicated problem. Especially, what is a complicated problem is the celestial mechanics, the motion of the planet. And from the Newton solved the two-body problem immediately. You know the two-body problem. Do you know what is a two-body problem? Okay, then Newton solved completely the two-body problem. What is the solution? Can you describe the? Maybe can I ask? Which kind of the motion is possible for the two-body problem? Hydrogen. Hydrogen is a quantum mechanics. I'm asking classical mechanics. Newton. Newton's two-body problem. When you hear that, oh, Newton solved it, then what he found? I'm not talking the Newton's equation of motion. He applied this to the two-body problem. And he classified the motion. Which kind of the motion is possible for three different kinds of motion? Do you, understand my English? Okay, anyway, so maybe you understand because you tried to answer in hydrogen. That means he knows my question. Maybe you don't get it. Then the last one. He says, sir, I'm sorry, I'm asking you, what kind of the motion in the three kinds of the motion in two-body problem in a planet? Celestial mechanics. Three different kind of motion exist in Newton's two-body problem. You don't get it? Okay, then the next one. I'm asking very simple question, actually. Three different kind of motion. You don't know. Actually, you know it.